So our next speaker is a software engineer. Is it Miro? Miro? Miro.
Yeah, it's a mirror.
Miro. Right. And also a web performance GDE.
Yeah.
He also lives in the Netherlands, where he enjoys baking healthy cakes. Tonight, he's going to be telling us about. Okay, yeah, give it up for healthy cakes. Tonight, he's going to be telling us about building adaptive web apps. So, preheat your ovens to 180 Celsius and put your hands together for Medhat, Dawoud.
Well, good evening, everyone. I'm so happy and honored to be here among a lot of experts and a lot of enthusiasts in the performance community. So please give another round of applause for ourselves, for our community. Yes. So this presentation is going to be long because it was made already for another conference talk that will be in 2 days in Berlin. So I will be super fast, but please bear with me. And if you have any other comments or something to discuss, maybe we can discuss after or reach out to me on Twitter. So talking about how to build an adaptive web application, this is me. As I said, I'm a senior software engineer in Miro and a Google Web expert in web performance. And who here likes free swags? Yeah. I'm in the wrong room. You know what? Okay, there is some free swags will be in the back after my talk. So please go and treat yourself. So without further ado, the first step for any performance problem is to measure, right? So starting from measuring with lab testing, or also known as synthetic testing, using Lighthouse or something, and you did a great job just reading all the recommendations and did everything, and you get a great score in the Lighthouse. And I am telling you, don't believe this guy, because this guy is not real. Okay, so you need more to focus on RUM testing or field testing, so to really know your user. So starting from that, using Crocs or any other vendor that most of them are being here in the room, so you can learn about the core vitals, learning about the different devices that they are joining your website from, different internet connection as well that they are using for your website, and based on that, with all other metrics, you're gathering information, and based on that, you can take decisions. Performance is not an easy thing to do, as we all know, and it's very costly. So you have to know what exactly is beneficial for the user before moving on. And you did all the static things, all the recommendations. However, there is some variables that every user is joining from a different place. And there's no one size that fits everyone. And web is full of challenges. That's what makes it exciting for us as well. You don't know from which size, from which screen size, I mean, from which browser, and even from the same browser, might be different versions that you don't know whether it is supporting something or not, from which internet connection, and what's the hardware that the user is using in order to access your website. So you have two solutions. The first one is to build it for the lowest condition, the user with the lowest condition, and this is a guarantee that it will work for people with better devices, better internet connection, and so on, or to build it for user with adapted to the user whenever they have better condition, you are providing some more things. This is also known as progressive enhancements, and this is providing obviously the lowest user experience, but this is the best user experience. So every user is having an experience that fits their device and internet. So we have 5 variables, basically. The device screen sizes, you will never guarantee which one. Browser support, user preferences, device hardware, and internet connection. So we will get one by one and give some tips how to mitigate these problems and make it adaptive for each user. Starting from the screen sizes, really quick. The smallest unit for any modern web application is components. So we need it to be just responsive like water, or like cats, because cats are liquid as well. So using media queries that has been supported for, like 10 or 13 years right now to build different sizes. So it can be accessible and visible for each user. So the shameless plug, this is how my website is. So in different sizes, it's still accessible, it's still visible for everyone. Nowadays as well, you can use not only query strings, you can also use a container query. You can also use container query, not only media query. Media query is depending on the viewport width, but this one is container width. And surprise, it is supported everywhere in major browsers, so you can use it today. You don't have to wait. Another thing that I'm so happy that has been explained earlier in Kara's presentation, that you can provide different image sizes based on if it's a user uploaded image using something like Sharp or Image Magic, or using something like Cloud Narrative, or even you can implement it yourself using something like Tumblr. So you provide different screen sizes, a different image dimension. Based on that, you can save some few megabytes. Can also do that using responsive design. The other one is to generate the images. This one is to just serve the right image size for the right screen size. So now we mitigated a little bit this one, and this one is the most obvious one, and every website I think is doing that. So let's have a look into the browser support. In browser support, this is not a cheap one. You have to do some things. So for example, here you have to provide different versions of the video. So if this browser is supporting WebM, for example, which is more compressed and smaller version of the video, you can provide it. Otherwise, you fall back to the MP4. Same for picture. If you are providing AVIF or WebB, which are smaller, much smaller than JPEG, so you are going to fall back to the worst. And finally, if you are not supporting any of them, you can just view the image in JPEG. Here's a small example. If we have different versions, JPEG, WebP, and AVIF has different sizes. Of course, AVIF is the smallest one. However, you have to check and provide all of them because, for example, AVIF is not fully supported yet on each. So just pay attention to that. Also for JavaScript, if you have any API that is not fully supported, you can check it like that and provide a fallback or polyfill for it, or a different experience. The most important thing is to provide the core experience for each user to use, and any new or an added thing to the user added just progressively. Also, there is something called CSS support that you can use in CSS. And based on that, for example, this colon has a selector. If it's not supported by this browser of the user, you can also check using that and provide a different way to select stuff over here. So these are all ways to make just adaptability for whatever the browser the user is using. And this surprise is fully supported as well in major browsers, so you can use it today. Another thing, we at Miro as well is using something called off-screen canvas in order to make the canvas rendering faster. This, unfortunately, is not fully supported on Safari yet. So this makes us make this a check every time we're using any feature from these unsupported one, whether it is supported yet or not, so we can use it. So now we mitigated as well the browser support, so we can now at least find out whenever the user is accessing for a different browser, whether we can give them the same experience or a different experience. So now, this is a small one about the user preferences. And I'm not sure if everyone knows that, but actually in HOS, you can set your preferences. So for example, this one is reduced transparency, or prefers a dark mode or anything, or maybe prefers to have reduced data, safe data. So if the user is setting that, we are supposed to react into that. So first one is very obvious one, to just support the dark mode by default. Second one is prefers reduced motion. This, if the user is setting it as a user preferences, you can just do a different thing inside it. If you have animation or something, you can disable it based on this CSS. And another one is prefers reduced data. This is very important if the user is setting that, so you can save few megabytes in the backgrounds or something using this. Another thing, if the user prefers as well transparency, less reduced transparency, you can just set a different transparency based on this media query. These two in particular are affecting a little bit our performance for slow devices or low-end devices. So we can pay attention to that. Unfortunately, the reduced data is not fully supported yet, but the reduced motion media is fully supported. You can use it today. So just move on to the two most exciting ones. The first one is device or hardware. So we all know this one, that Chrome used to be eating all the RAM, right? We all know this one. However, recently, they started to add this feature, which is by hovering over any tab, you can say that tab is using this amount of memory, which making them say, it's not me, it's them. And developers start being like that. Oh my God, we used to blame Chrome. Now we need to do our work. Cool. So we have two exciting APIs that we can use. The first one is device memory, which is returning to you in gigabytes the number of capacity for the memory on the user's device. What's important about that? That you can serve a different experience for the user based on the available memory on their devices. So, for example, some e-commerce website or something, instead of serving always 3D model for this thing, for this product that they are selling, if the user has like maybe 8 or less in this device memory, you most probably will hurt this device and user experience by providing a 3D model, which is a huge one. Instead, you can serve like fixed image or maybe small video and so on. And this is supported only on the Chromium-based website, browsers. And there is no clear plan based on our discussion earlier when this will be supported in other browsers. This one is a hardware concurrency that is returning the number of cores of this current user's CPU. And based on that as well, you can either serve more heavy work, or at least you can decide the max number of web workers that you can run on parallel and make multi-threads. This one is fully supported in major browsers, so you can use it. Just some general tips or advices for this one. So first of all, if you have zoom in and out or animation, and you find out that the user device using these APIs is slow or not big or capable enough, you can just disable that. It doesn't hurt the core functionality by having buying this product or converting or whatever. But you can make it like a progressive enhancement. If the user has this ability, just provide more zoom in or magnifier, as you can see usually in Zoom or something. On Amazon. So next, image carousel. If you have image carousel, image gallery, you can always load the first one as the largest contentful bins, of course, eagerly, and the rest can be just lazy loaded or on intent. Every time the user is hovering over the next button or previous button, you can load them afterwards. Another one, which is very interesting for people who are enthusiastic about IMP, is usually asking people to yield to the main thread. But actually, this process of yielding to the main thread and sending the control to main thread and come back and cutting each task is affecting performance for low end devices. And if you have any argument, and I know someone will have, this guy in the back, it's Jeremy. So please reach out to him afterwards. Yeah, hey, Jeremy. So now we have mitigated and make different sizes for different users. So let's move on for the last and most exciting one, which is internet connection. We have different internet connection for each device, for each user, and we don't know even for these countries. It's not only for developing countries or something. If you are in the airport, if you are in far away inside a cafe or something, you might have bad internet connection. So we need to make it accessible for everyone. Here's an example that for the past 10 years, for the top 1,000 websites, actually the number of the total kilobytes are being increased. So for the median desktop, it's 33% more, and for the median mobile, it's 10% more, which is a lot. But it's okay. We can expect that. However, the forecast for the internet connection to be in 2030 for the 5G to take over everything. However, we're still in 2023, right? So 25% at least of the population of the internet are still using either 2G or 3G. So we need to still make this accessible for them. Good for us that by time this is getting less and less and less. So please, we need to still make some work in performance in order to adapt for these people. So an example for people who are building this adaptive loading is YouTube. If you are throttling here the network and CPU, you will find out that by default, the auto will be the lowest quality. Have you seen that before? Yeah, everyone? Okay, so this is adaptability. YouTube is adapting to your internet connection. So how to do that? There is something called Network Information API, which is still experimental, using window navigator.connection. It comes with this list of things, and the most exciting one for us might be effective time, which might not be very accurate for some cases, but this is for now we can use it at least for the major browsers that are supporting it. So for people who are using React, this you don't have to write it yourself from the window navigator a connection, you can use this provided hooks, which is React adaptive hooks, coming and implemented. You can just exit from this link. I will share the slides later. And based on that, you can just use a custom hooks and check for the effective connection. A very good usage for that is to provide different experience for different users. So for example, if you have this connection type and you are switching between them, if it's 4G, so you provide a video, which is good experience. If it's 3G, you provide an image, which is a mid quality. And finally, if it's 2G or others, you are serving the lowest quality of it. So for this one, it can be 1 meg, which is okay for a 4G connection. And for this one, it's 2G or 3G. It can be only 30 kilobyte loaded, which is okay, adapting to the user. This one is only supported for all the Chromium-based browsers, but not all of the other ones. And here's some recommendations as well. First one, if you have a user with slower connection, so you can adapt to that by loading less items in the same page. So if you're usually loading pagination with like 20 items or 50 items, and find out that the user is connected from 3G, you can fetch only 10, and so on. This is better user experience and adaptability for the user. Another thing, change a heavy custom fonts. Some people are using crazy fonts for their websites, which is okay. However, you need to adapt to the user. If the user of your website is visiting from slow connection, you can just rely on a system font, which is lighter and doesn't require more downloaded data. So another exciting thing that comes with the same API is save data, which is still a user preference as well. Save data is something that if you enable it and the user, if the user enable it and you use it and check that, you can provide a different experience. Have you seen that before in Twitter? No one has enabled the save data, right? You have. All right, that's great. So back in the days, which I learned today, this save data was being opted in for the user with slow connection. Just pop up in front of the user and ask the user to opt in or not. Currently, it is using the same settings that the user can do for preferences I have shown earlier. And based on that, you're loading this blurry image, and if the user is interested to see it, just click on it or hover over it. If it's a video, you can provide the video, which is not auto play like usually on Twitter or X now, or you can provide a different version, which is only audio, which is just a smaller version. So as a recap, we learned how to mitigate or adapt for the device of the user screen, and how to adapt to the browser support and make different versions, how to adapt to the user preferences whenever they are asked for lower motion or less animation or transparency, we can do that, how to adapt to the different devices capabilities for the user, and finally the internet connection to provide the best user experience ever. Here's a bunch of resources. Check it out in your own time. If you find anything interesting today, please just follow me on this Twitter. If we don't have a chance to discuss anything today, just send it out and we can start discussion online. Thank you very much for listening.